Okay, good morning, afternoon, evening, everybody. Welcome back to the workshop. Today, we're going to get started with a little overview of Ocean Networks Canada as our data relates to acoustics and imagery data. And let's get started. So before I get into the presentation, I'd like to thank our host nations at Ocean Networks Canada. Our facility is located on the traditional territories of the Sanghees, Esquimalt, and Wasanich nations, whose traditional territories and historical relationships continue to this day. And quick overview of what I'm going to talk about. I'm going to go over some of the history of Ocean Networks Canada for those of you who aren't familiar with us, and we'll talk about the cabled observatories and then some of our mini observatories, and then acoustic and imagery data in general at ONC, the ways we're trying to solve the problem of mining these data, and some of our manually annotated data sets. So Ocean Networks Canada has been around for over 10 years now, and initially it was two different cabled underwater observatories. The Neptune Observatory is about 800 kilometers of fiber optic cable stretching from the west coast of Vancouver Island to the spreading ridge of the Juan de Fuca Plate. And the Venus Observatory is a shorter loop of fiber optic cable coming out of Vancouver. And both of these observatories have, at the square boxes that you see, nodes that instruments can be connected to of all kinds. So it was designed to operate for 25 to 35 years. And these fiber optic cables allow for really high power, high bandwidth data collection that's interactive. So we're able to see data coming in 24 hours a day, 7 days a week, and we're collecting data from many different types of instruments. And all of these data are available for free on the internet. So this is a little look of what an observatory, one of these observatory nodes might look like. The orange piece is the node, and then there's cables coming off to platforms and different instruments. And we have many different types of instruments on this observatory. So just to look at a few of them, there's CTDs, ADCPs, we have a water sampler, seismometers, cameras, sediment traps, of course, hydrophones, and lots of other oceanographic instruments on all of these different nodes all over the Pacific Ocean. So zooming in a little bit on specific instruments that we're looking at in this workshop, we have hydrophones at all of the instrumented nodes on both the Venus and the Neptune observatories. And over the last few years, we've also started collecting array data. So there are 4 locations, the ones in red, that have 4 hydrophones in a box shape for, spaced 1 meter apart so that we can do localization. There are also cameras on many of the nodes of Neptune and Venus. And as you may be putting together already, some of these cameras are in the same places as we have hydrophones. And we even have some specifically set up to have the hydrophone in view so that we can be associating the things that we're seeing with the sounds that we're hearing. I won't get too far into detail about this because I think this is going to get talked about later today. In the time since the original observatories were deployed, we've been expanding our network through building partnerships with Indigenous communities and empowering them to collect their own data. And some of these locations we've deployed mini observatories at that also have hydrophones and cameras. So the orange spots are the hydrophones and the red spots here are the cameras. On top of all of these data we're collecting, we also have video from mobile platforms. We have video from our deep sea crawler Wally in Barkley Canyon, and also from the ROVs, of course, that we use to deploy and maintain our instruments. And they're not just used for this, but they're also used for collecting samples and doing visual transects so that we can better understand the sediment, the structures that we see, when we're at the hydrothermal vents, and also all of the diverse marine life that we see when we're doing our deployments. So as you might imagine, with all of these instruments, we are collecting a huge amount of data. Our archive is over a petabyte of compressed data. And of that, over 300 terabytes of our archive is video data, and over 600 terabytes is acoustic data. And our hydrophones at this point, because we have so many, are collecting 250 gigabytes per day of data. So with so much data, there is the chronic issue: what is in the data and when is it there? And at Ocean Networks Canada, we are not machine learning experts. We are a data service provider. So we're doing our best to find ways to get these data to you and find ways to help scientists find what is of interest to them. But of course, we're very open to collaborations with folks who are doing machine learning. And there's a few ways that we have to try and figure out what's in the data already. One of them is, of course, the old-fashioned method of download it and view it. There's two ways to download the data. We can use the graphical user interface on our website on the right here, or we also have API tools that can be used in R, Python, or MATLAB to download the data. We've started trying to make it possible to view the data, and this is, of course, much more complicated with complex data. We do have a plotting utility for scalar data, but it's a bit challenging to figure out how best to view hydrophone data. For the moment, we have this Search Hydrophone Data Viewer page that shows pre-generated spectrograms for each 5-minute file. Unfortunately, the parameters of these spectrograms in the viewer cannot be changed. So if you're looking for blue whales, it's going to be really hard looking in the broadband data. However, we are working towards having that capability in the future, and we also have some of that capability in our download services. Of course, going through one spectrogram at a time is not the fastest, so we've started implementing ways to get a higher level view of what's happening in an area. We have this data preview page where you can look at the spectral probability density plots for the day and also long-term spectral averages. So for those who are not familiar, this plot on the right that looks like a spectrogram is in fact an LTSA. It's showing an entire day. And that broadband signal we see in the middle of the plot has the characteristic banding of Pacific white-sided dolphin clicks. So this is something that some of the biologists could take a look at and know immediately what happened in the day. We also have ways to visualize our video data. Of course, we have CTube Pro, which allows us to look at the video data both from our cameras and also from our mobile platforms. And in CTube, it is possible for people to make annotations. We have our data stewardship team make annotations of all of the marine animals they see during the ROV dives. And those annotations are available for people to use. We also have digital fishers. This is a way we've started trying to engage citizen science to annotate our video data. And it's a little bit gamified. The more you play, the more you get to learn, the more species you get to identify. And as you get better at this, it trains you up on new things to look for. And these annotations are also available should somebody want to use them for image analysis. So of course, the best thing to do for mining these data would be machine learning. We have far too much data to go through by hand, and it's much more efficient than manual efforts. But again, we are not machine learning experts, but we can contribute to the effort with high quality training data, which we all know is required to validate machine learning algorithms. And there's quite a few different data sets we have. For now, with image and video, we have the digital fishers annotations. There's the annotations from CScribe and CTube, both for video. And for acoustic data, we have opportunistic file level annotation checks that we make during our data quality checks. And we're also starting to produce curated data sets, which is, as I'm sure you can imagine, very slow going, but they're coming. So one such data set has already been produced. I personally annotated 10,905 signals in about a year of data from Barkley Canyon. I was looking at the first 4 days of each month. And there's quite a few species in this data set. It's a very biologically active region. About a quarter of the annotations could not be identified to species. This was because of either low signal to noise ratio or sounds that sound like other sounds. For example, sometimes humpbacks and killer whales can sound very similar, especially if you only have one or two signals to go on. Or some of the delphinids do not have very well described sounds or make sounds that are too similar to other delphinids to identify to species. But these annotations are still in the data set. They're identified as unidentified, and then the species that I think it might be, or several species that I think it might be. 3/4 of the data set I was sure about, so there's lots of annotations of specific species in this data set. We're also hoping to start engaging citizen science annotators in the future. We're working towards producing an annotation platform where people will be able to adjust the spectral parameters of what they're viewing, look at waterfall displays, listen to the data back, and we're hoping to produce something somewhat like the digital Fisher system to engage citizen scientists in annotating. And this platform will also be available to experts who want to annotate their data in the cloud. And the intention is to put all of these annotations online. They're all available already for machine learning scientists to work with. Some of them are harder to find than others, but we're very, very happy to share. So if you're interested in any of these, please email me for the acoustic data. And our next presenter, Fabio DeLeo, is the person you would want to contact for imagery data. So thank you very much. And if I have any time, I'll take questions now.
Hey guys, we do have 5 minutes for questions if anyone has anything for Jasper. And if not, then we can get Fabio to start screen sharing and get him set up.
I have a quick question, actually.
Sure. It's also on the chat here. Go ahead.
We saw pictures of the nodes out there. How do you go about actually physically putting in new equipment or taking out old equipment?
So we use an ROV, and all of our connections are wet mate connectors, so they can be connected underwater.
Oh.
So we just haul it all down, do it by machine. Yeah.
Cool.
Question in the chat is it possible to search the annotations for keywords?
It's possible to search the imagery data annotations for keywords. We're working towards being able to search the acoustic annotations that way. Right now, they're searchable by species. And the acoustic annotation system is a little messy right now. So if you want acoustic annotations, send me an email directly and I will find you what you're looking for.
Jasper, hi, it's Oliver. Quick question. And I think maybe at some point I knew the answer to this, but I forgot. So bear with me here. Where are like all your data stored? This 1 petabyte of acoustic and video data. I have a feeling it's kind of, because I'm wondering as a Compute Canada user, am I close to that data when I say play around on one of the servers that are hosted at UVic, or what's the connection there?
Yes, so you could not be closer with your UVic Compute Canada account. Our primary archive is hosted at UVic, and then we have a backup archive in Saskatchewan should the big earthquake take out the primary archive.
All right, thanks. And then I guess follow-up question, is this something Ocean Networks is working on to, I guess, provide as a Compute Canada user, how, like, I guess I can't access your data. It still happens through the API and there's a download process, or like, is that something that maybe in the future as a Compute Canada user, you could directly access your data?
So it is about as direct as it can be.
Okay.
Yeah, part of the challenge is that the data are compressed, but we've recently switched to FLAC. So now you don't have that lengthy uncompression step. You can just read the FLAC, at least for the acoustic data. And Yeah, while our data, I imagine, are not directly on the supercomputer, it is much, much faster to download data on campus than it is off campus. So if you're using that supercomputer, it should be, and I mean, in my rough estimate of my personal experience, about 4 times faster.
Okay, thanks.
Couple more from the chat. How much participation do you get from people voluntarily? Is citizen science contributing a lot?
This one I'm not sure of. I'm not deeply involved with digital fishers, and we don't have the citizen science platform yet for acoustic data. But we certainly do have some citizen engagement, I know for sure. We at one point had a video of what was it? It was an elephant seal that was like hundreds of meters deep, catching a hagfish. And that was found by somebody in Europe who was just watching out of interest, and then emailed us about it. So there's definitely people who are interested and engaged.
Very cool. And the other one is, can you show the map of the hydrophones again and point out which are closest to real time and discuss how ONC could support detection in real time or near real time?
Sure. Let me just get my screen share back up. All right. So, yeah, I guess I'll show, where's the map that I'm looking for? It's being slow. Here we go. So on this map, all of the ones that are not, I guess all the ones that aren't the Venus ones, are delivering data in near real time. We say near real time because the data are chunked into 5-minute files, and once the file is finished being created, it gets sent to shore. So there's a little bit of a delay, about 5 minutes, sometimes 10 minutes if the pipeline's really clogged, but it's pretty close to real time. In the Strait of Georgia, it's a bit slower in terms of what's visible online because we've been asked by government agencies to put a 4-hour delay so people can't use those data to find the southern resident killer whales. However, we have in the past set up pipelines for people needing real-time data to access those data immediately. So you may or may not be aware of this, Val. I've been in contact with some of the folks from the Hallow project, and I am intending to set that up for them when they're ready to be using our data in their model. We do have a couple locations that are lacking in being able to be that fast, that near real time. One of them is Cambridge Bay, which is way up at the top there. I think a couple other locations have this issue as well, one of them being China Creek on the island. And that's just due to bandwidth issues. It's quite expensive to send data from Cambridge Bay and from places that don't have very good internet access. So those ones, we get a couple files a day, and then once a year we go and collect the hard drive and then upload the data that way. So most of the data are near real time or can be, and there's a few exceptions.
I'd suggest in the part D, second question there, how could they support it in real time in the future? You're probably looking at, especially in that northern one, having the machine learning deployed on the rig so that it's happening and catching it there as just additional data, and then you're just downloading that data.
Yeah, definitely. Yeah, and that is something that we are interested in doing as well, is hosting algorithms at Ocean Networks Canada to be rapidly labeling incoming data.
Right. And I believe one of the presentations we'll see tomorrow is from Hallow on some of the work that they're doing. All right, so thank you so much, Jasper.